Hey gang, Mr. Zacek here again, and we are today looking at circles 4, which we're calling interior and exterior angles. So this is just the fourth day in our circles unit where we've been focusing on angles. And today the essential question that we want to answer is how do we find the measure of an interior and an exterior angles in a circle, and when we're referring to those, we're referring to the vertex. So the key concept that we have is, just from review, is identify the vertex and the intercepted arcs. So in our first one here, okay, here's our vertex, here's our intercepted arc, and that's called a central angle, and of course we know that that equals the arc. And then our second concept that we've been working on the last couple days is with inscribed angles where the vertex is on the circle. And here's our angle, here's our intercepted arc, okay, and an inscribed angle equals half the arc. And of course we want to keep in mind that, so to find the angle we take half of it, to find the arc we double it. So I wanted to review a little bit of vocabulary with you today. The first term that we have here is the word chord, and a chord is a segment with two endpoints, okay, on the circle. And so you have this diagram here underneath the word chord, and you can see that we've got a couple chords drawn in here. Here's a chord, there's a chord. Notice that those intersect inside the circle. The second thing that we have here is the word tangent, and a tangent is going to intersect the circle at exactly one point. So intersect at exactly one point. And we have two tangent lines here, and this particular picture that you're looking at, and there's one, and here's the other. Okay, so they can intersect outside the circle. They don't always have to intersect outside the circle. They could be parallel lines. And we're going to introduce a new vocabulary term here today, and that word is secant. And a secant intersects the circle at 2 points, but it extends outside the circle. So it intersects the circle at 2 points and extends outside the circle. So this diagram above, we see two secant lines. Okay, it's like a chord, but then we just extend it outside of the circle, and you can maybe follow along and how that's going to get us toward our essential question with giving us an exterior angle. So the first relationship that we have here is interior angles, and when we talk about an interior angle, what we're referring to here is an angle whose vertex is inside the circle. So let's just identify that. An interior angle is an angle whose vertex is inside the circle. Now, we've already talked about one specific case of interior angles as central angles, though when it's at the center, and that's a special case. We're not going to be looking at that here today, but that is one example of an interior angle. And so we can have an interior angle, as in this first example here, when we have two chords that intersect, they form an interior angle. And the relationship here, if we read along, the measure of an interior angle is equal to half the sum of the intercepted arcs. All right, so there's some math terminology that we have in this. The measure of an interior angle is equal to half the sum of the intercepted arcs. So I was getting a little bit ahead of myself, but let's get back to this example. We've got two chords, and we have an interior angle. It's the vertexes inside of the circle. Now we know from earlier that when two lines intersect, they form congruent vertical angles. So we should recognize immediately that those two angles that I've drawn there are congruent to each other. Now, let's call this x. Now the question becomes, what are the intercepted arcs that we're referring to here? And so what I want you to do to see that is follow your chords to where they intercept the circle. So start at the vertex, follow it out. All right, there's where it intersects the circle. Follow it out the other way. There's where it intersects the circle. That's one of our intercepted arcs. And then if we go to the other side, we have a second intercepted arc. And let's call this arc A and this arc B. So in this example, the measure of the interior angle, so the measure of angle x equals 1/2 the sum of the measure of the other two arcs. So half the measure of arc A plus the measure of arc B. That's not really how we label arcs. Let's scratch that, okay. And let's just call that A plus B. So, A plus B. All right, so now as a second example here, you see, we can also have a chord and a secant. So, in this particular example, we have a chord and a secant, okay? But again, the key is the vertex. Where is the vertex? So the vertex of this particular angle is inside the circle. So let's call this our angle here. Let's call this our x this time. And again, so what are the intercepted arcs? Again, recognize your vertical angles. So those two are going to be congruent to each other. And we want to find, well, it intercepts this arc. And on the other side, it intercepts that arc. And so measure of angle x, let's call this A, let's call this arc B, equals 1/2 the sum of the two intercepted arcs. So we put those in parentheses. Okay. All right, now that we have those, let's try some with some values in it here in our practice ones. And in the first one, I want to find the angle. So in this example, let's say that this is our angle. We'll call that x. And we know that this arc here is 30 degrees, and the other arc that we have is, let's say, 100 degrees. Okay, so find the angle. I'm just going to walk you through the thought process here. Vertex is inside. So the angle equals half the sum of the arcs. So that's kind of, just generalizing what we've been talking about here. So in this particular example, again, it's about identifying what those arcs are, those intercepted arcs. That's the real key to this. So here's our vertex. Follow them out. There's one of my arcs. Here's the other vertex. There's the other arc. Okay, so x equals 1/2 100 plus 30. Some of you may be wondering, does the order of 130 matter? The commutative property tells us that it does not matter. Okay, and we can combine like terms here. 130 and half of 130 is 65 degrees. Okay, so 65 degrees. Now, just as a note here, kind of an add-on, sometimes what you can then find after you're given that information is that angle x and this angle that I've marked in red, those two are supplementary. So if you want to find that, you can subtract and you get 115 degrees for that angle. Okay, and those two, they form a linear pair. So, that's not the focus of this particular lesson, but just to be aware of that and when we're doing those things. All right, so again, let me review. The vertex is inside the circle, so the angle is half the sum, and so we add those two arcs together and multiply it by 1/2, which gives us what we are looking for. Now, in example 2, we're going to look at a situation where we know the interior angle and we're trying to find the arc. So in this case, I'm going to say that this, okay, sorry about that. This arc is 50 degrees. I know that this angle here is 100 degrees. And I'm trying to find this arc. Let's call that arc A. So again, in my thinking, I'm looking here, what do I know? Well, I have a vertex inside. With that vertex inside, I'm thinking that the angle is half the sum of the arcs. So I'm just, kind of abbreviating there. What are those arcs? Well, I'm going to use my highlighter here and follow this out. Here's one arc. Here's another arc. So now that we have that, we can set up our equation. Those are our two intercepted arcs. So the angle, which is 100 degrees, equals 1/2 A plus 50 degrees. So we have ourselves a little bit of a different scenario in this case. Now, the algebra here that we want to do is first we'd like to eliminate that 1/2. You could distribute that would be fine, but it's a little simpler if instead we multiply both sides by 2. Now, when we multiply both sides by 2, on the left side we get 200, and on the right side, those 2 divided by 2 is 1. And when we multiply something by 1, it doesn't change the value, so it just becomes A plus 50. So again, what you do when you're looking for the arc is multiply both of those sides by 2. That eliminates your fraction. Now we're going to subtract 50, and you get 150 equals A. Now in class we'll do some of the ones that maybe are a little bit more involved with that, but those two give you the two basic types of questions that we have for interior angles. All right, now exterior angles. An exterior angle is an angle whose vertex is outside the circle. And obviously it has to have a connection in some way. And here is the relationship. You can read along with me. The measure of an exterior angle is equal to half the difference of the intercepted arcs. Half the difference, okay? And of course, the word difference to us indicates that we're going to be doing subtraction. Or sum and addition, difference means subtraction. So we have 3 scenarios that we need to be aware of. Okay, the first is when you have 2 secants. And when you have 2 secants, here's our exterior angle. I'm going to call it X. And here are my 2. Now follow those secants along, and here's where we get our 2 intercepted arcs. One is here, the other's there. And A and B. So X equals 1/2 A minus B. Now you always want to do the larger arc minus the smaller arc. And we need to remember with subtraction that the order matters. If you flipped that around, you'd end up with a negative angle. And we're not looking for a negative angle. So those secant, those ones are the most straightforward. The next setup we have is a secant and a tangent. So what happens here with these two intercepted arcs, let's call this x, a, and b, just to be consistent with that. The thing you need to recognize here is that with those two arcs, they're adjacent. They touch each other, but they're separate arcs. Again, that little highlighter likes to straighten itself out. So the exterior angle here equals half the difference. Which one is larger? A. So it's A minus B. And then the last scenario that we have is tangent. And again, tangent only touches the circle at one spot. So what are we going to see here? Well, we're going to see that these two angles will complete the whole circle, our two arcs. So there's one of our arcs, and here is the second intercepted arc. And so I'm going to go ahead and call those two arcs A, B, and let's call our exterior angle X. And here it is again. Exterior angle is half the difference. The larger minus the smaller. So that's A minus B. So let's do some where we have some values. And in the first three, I'm going to give you ones where we have to find the angle. And in the second three, I'm going to give you ones where we have to find the arc. So let's call this, example 1 here. We're looking for our angle. Let's call that X. Excuse me, X. And let's say that this arc that you have here is 90, and this arc is 30. So I'm thinking, here's my thinking, okay? Exterior angle, half the difference. I just want to reiterate that. So the angle is X equals, now what are my two arcs? Well, here's one of the arcs, and here's the other arc. So we get 1/2, larger minus smaller. So X is 1/2, 90 minus 30 is 60, and half of 60 is 30 degrees. So that's when you have the two secants. Now in the middle here, we've got another one. Let me just put a different color up just so we can make sure we can keep that straight as we're looking at things. Again, we're going to be looking for the angle. Let's call it X. And let's say that this smaller arc here is 70 degrees, and this larger arc is 170 degrees. So here's our thinking. Exterior angle equals half the difference. Okay, difference means I have to have two values. So I look at that point of tangency. That's going to be key to identify. And I see my two arcs. So my angle, which is X, equals half the difference, 170 minus 70. So we have half of 100, which is 50. Now our third example is the one that they really like to kind of add some little different tricks here, and we're looking for the angle. And a lot of times what just happens here is you're only given one of the arcs. So let's say that this interior arc is 120 degrees. And you're like, well, I need both of those arcs. How are we going to find both of those arcs? Well, always come back to, what do we know? We know all the way around a circle is 360. So if we do 360 minus 120, we get 240 degrees. So the larger arc here is going to be 240. And so that's the thing to keep in mind with these two tangent ones, is all the way around is 360. So here we are again, exterior angle, half the difference. Exterior angle equals half the difference. So x equals 1/2 240 minus 120. Okay, the smaller one, or the larger one minus the smaller one. So half of 120, and that is 60 degrees. All right, our final three here are going to be where now I'm going to give you the angle, and we're going to need to find the arc. So in our first example, let's say that this is 20 degrees. Okay, now I'm going to be looking for this arc. I'm going to call it A, and I know that the other arc that's out here is 80 degrees. So again, just here's our thinking. Exterior angle equals half the difference. So the difference of what? The two arcs. Here's one of those arcs. Here's the other arc. So our exterior angle is 20 equals 1/2. Now, which of the arcs is larger? Well, obviously 80 is larger than A, even though we don't know what A is. We've got that fraction 1/2 again. So our algebra says we're going to multiply both sides by 2. The inverse of that, the 2's divide out. We're left with 80 minus A. So we need to solve for A. So we subtract 80, okay, which comes out to be negative 40. Don't forget to bring down that negative A. We don't have a negative arc, so not divide by negative A, divide by negative 1, and 40 equals A. So that's how we go and find the arc. Now, here we are. I'm going to have another one where we have to find the arc. And in this case, our angle is going to be 30 degrees. So we have a 30-degree angle. And this time, I'm looking for the larger arc. I'm going to call it B. And I know that this smaller arc here, from the tangent, point of tangency to where our secant intersects this line, has a 45-degree measure. So again, exterior angle, the vertex is outside the circle, equals half the difference of the intercepted arcs. So my exterior angle, 30, equals 1/2. All right, which one is larger? B minus 45. So here we go. We're going to multiply both sides by 2. And we're going to get 60 equals B minus 45. To solve that, we're going to add 45. When we add 45 to 60, we get 105 equals B. Okay? All right, we should pause for a little movie trivia. What movie was this from? See the Cliffs of Insanity. All right, write that movie name down on your notes. And then let's look at the last one. This one is one that often gives students a lot of trouble, and we're going to help you out here. All right, let's say our angle on the outside here is, let's say it's, I'll just use 30 degrees here again. Nah, change that. Let's call that 45. Okay, all right, 45. Now, all you may be given sometimes is x for this. And again, don't freak out. What do you know? Well, we know all the way around a circle is 360. Well, if this arc here is x, that means our larger arc is 360 minus x. So here we go. Our exterior angle equals half the difference. Now, what are we going to be subtracting? 360 minus x, okay, that arc minus x, the smaller arc. So do you see that? 360 minus x minus x. So your first step is going to be the same. And 2 times 45 is going to be 90. They're going to cancel each other out. 360 minus x minus x. Now here we can combine like terms. So we get 360 minus 2x. We're going to subtract 360. We get negative 270 equals negative 2x. And then we're going to divide by negative 2. And we're going to get 135 equals x. So one of our arcs is going to be 135, and then the other arc is 360 minus x. So that kind of gives you an overview of the type of questions you're going to see. Obviously, we're going to do some work in class and practice, and hope that helps. Have a good night, and I'll see you soon. Bye.